In part 2 of the normal distribution, we are going to look at how to use Table A. Specifically, we're going to find the proportion of values in a specified interval in a normal distribution using Table A. And then we're also going to find the value that corresponds to a given percentile in a normal distribution using Table A. So we are going to continue by looking at the example with the EPA fuel economy of certain automobiles. So we left off and we were on letter G, and the question was, what percent of autos get less than 35 miles per gallon? So when I look at where is 35, that looks to me like, well, here's 37, so 35 is going to be about right in here. So less than 35 will be the area in the normal model to the left of this. Well, this is a case now where the 68, 95, 99.7 rule is not going to help me. So what I'm going to do first is I'm going to find how many standard deviations from the mean 35 is. And then fortunately, there is a table that statisticians use to get these probabilities that are a little weird, like where it's not just 1, 2 nice whole number standard deviations away from the mean. So we need to find our z-score. So I do 35, the value minus the mean, 28.4, divided by the standard deviation, and I always round my z-scores to 2 decimal places. And so I get a z-score of 1.65 above the mean, which looks about right in my picture. I estimated a little more than 1.5 standard deviations. Now, what I do from here is I'm really asking myself, what's the probability, or what proportion I could even say, or what percent, I'm going to write this up here, what percent of values have a z-score that are less than 1.65? Okay, so there's the notation I'm going to use. And to find this, I'm going to go to what is known as Table A. You will be given this table, and you have it in your possession now on the AP exam. So Table A is showing you your probability, or you could even think of it as the proportion for that area under your density curve. So we want to know the chance of getting a z-score less than 1.65. So first of all, notice that the way this table is set up, the areas that are given are to the left of your z-score, which is going to work out well for us because that's actually what we want in this example. So along the left side on this column is your z-score, how many standard deviations from the mean. So we're above the mean, so I'm looking at the positive values right now. And here's 1.6 right here. And I want 1.65. So across the top, it goes to the 100th place. So if I go over to, I believe, this value right here, that is giving me the probability of getting a z-score less than 1.65. I can see from the chart it's 0.9505, so I know that 95.05% of autos get less than 35 miles per gallon. We're going to use Table A to find a few more probabilities. So it says, on the driving range, Tiger Woods practices his swing with a particular club by hitting many, many golf balls. When Tiger hits his driver, the distance the ball travel follows a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? So the first rule of statistics is to make a picture. So I've labeled my mean, and now I am labeling the standard deviations below the mean. So I subtract 8 to get 296. 8 more would be 288. 3 standard deviations below would be 280. And then to the right, I would have 312. 320, and 328. And I want to know what percent So I'm going to use a capital P, which could be probability or percent. It's really going to be the same thing. What percent of the drives, these are the values, so I'm going to call that X, is at least greater than or equal to 290. So when I go over here to the picture, 290, it's probably about here, and I'm really being asked, so what's this region to the right of 290? Now, I can't use the 68, 95, 99.7 rule, so I am going to have to resort to Table A. In order to use Table A, I need to standardize my value, or in other words, find a z-score. So my z-score would be equal to my value, which is 290, minus my mean of 304, divided by the standard deviation of 8, toss it in my calculator, and I get negative 1.75, and that looks about right, not quite 2 standard deviations below the mean. By standardizing, what I've actually done is I have kicked up the normal distribution, I kicked it up a notch. When we standardize, my normal distribution has a mean of 0 and a standard deviation of 1. So it's not always necessary to redraw your picture, but sometimes it helps us realize what we're doing. So negative 1.75, I can now use my Table A to find this region here that I just colored in green in the standard normal table. So I go to my Table A, and this time I'm below the mean. So here's negative 1.7, and up at the top here is to the hundredths, so they meet right here. So this would be 0.0401. Now hopefully that doesn't look right to you, but remember this is giving us the region to the left, and we need the region to the right. So the easiest way to do this is use your knowledge that the area beneath this density curve has to add to 1. So if we just subtract the 0.0401 from 1, we'll get the probability or percent that we need. So my conclusion would be that approximately, I could say 96%, I'm rounding a little bit, of Tiger's drives travel at least 290 yards. All right, now we're being asked on a specific interval, what percent of Tiger's drives travel between 305 and 325 yards, and we're told to draw a picture. Now, you won't always be told that step, but it needs to become natural that that's your go-to thing to do. So again, I sketch a normal model, and immediately I always label right next to it with a capital N, my mean, and my standard deviation. Put my mean in the middle, and I count out 3 standard deviations in both directions. And now I look for, so where would 305 be? Well, that's going to be just a little bit to the right of the mean. So I'm going to label this one right here as 305, and this one here as 325, this mark. I could do it down below, I just didn't really give myself adequate space. So that region, I'm going to shade this in as what I'm looking for. So I'm asked, what's the percent? You could also think of this as probability of the drives traveling between 305 and 325 yards. All right, so empirical rule fails me, so I'm going to find my z-scores. So first, I've got my notation, my picture, and my probability statement. Now I'm going to find my z-scores so that I can use Table A. Okay, so my first z-score on the left would be 305 minus the mean divided by the standard deviation. Approximately 0.13, change that to an approximate, and I do the same for the other, 325 minus 304 divided by 8. My second one is 2.63, and I always look back at my picture and go, does that make sense? Now again, it's not really necessary to draw your second normal model, but what we've done is we've just transformed our data to the distribution, the standard normal of a mean of 0, standard deviation of 1, and we are finding between 0.13, we're just real close to 0, and 2.63, that region in there. So your pictures essentially look the same, it's just this top one is just a normal distribution with this given mean and standard deviation, and now you've transformed the data so that it's a distribution of z-scores, which always have a mean of 0 and a standard deviation of 1. So now, when I go to table A, I'm going to be finding the probability that my z-score is between 0.13 and 2.63. So we're going to need the areas associated with these z-scores, but I want to just conceptually talk through what you need to do once you have them. So if we find the z, or the area or probability that corresponds to the 2.63, that's going to be the entire area to the left of 2.63. If we also find it for 0.13, that's going to be just the area to the left. So how do we get the region exclusively here between the two? Well, hopefully you see it as a subtraction problem. If you take this area, which is the entire to the left, and subtract this area, it's going to leave you with just this yellow part that I'm scribbling in right here, which we need. Okay, so I am going to find the 2.63, which is on my other table. So I'm just going to say you look on yours and find it. I think it corresponds with 0.9957. And then I need to subtract the one area that corresponds to 0.13, which here's 0.1 and here's 0.03. So here's where they intersect. I need to subtract that, the 0.5517. to get approximately 0.444. So my conclusion is about 44% of Tiger's drives travel between 305 and 325 yards. So this final one is asking a different question. What distance, so we're not asked a percent or probability this time, what distance would a ball have to travel to be at the 80th percentile of Tiger's drive lengths? Draw a picture. Okay, so I'm going to do just a little estimating. So my normal model had a mean of 304. One standard deviation to the right by the 6895 would be 34 more percent. So one standard deviation to the right is going to 50 plus 34 is going to be about 84%. So I know that the x value that I'm looking for is going to be not quite one standard deviation to the right. I'm trying to figure out what is this x value. And this time, my given is that this area to the left, well, to be at the 80th percentile, this area here is the 80%. So this time, I'm given information from the body or the inside of Table A. So here I am on the inside of Table A, and I know it's not a negative value. I know that it's not quite one standard deviation to the right. So what I'm doing is I'm looking in here on the inside, and I'm going to find the z-score that corresponds to it. And I want it to be close to 80%. So down here is too far. Here's 79. And I'm just looking, is there anything closer? 81. This is closer, 70. 0.8023 is a little too big, okay? We want 0.7995 is going to be the closest we can get. And what is the z-score that corresponds to that? Well, it's going to be 0.84. So now going back to here, I know the corresponding z-score is 0.84. Now I need to figure out, well, what is the x value that corresponds to that? So I'm going to use my z-score formula where I take my value, subtract my mean over my standard deviation. I know, and we're just going to use algebra now, I'm going to plug in 0.84 from table A. Don't know x, my mean is 304, and my standard deviation is 8. So what am I going to do? I'm going to multiply both sides by 8, and then I'm going to add 304. Which I could also write like this. I could say, so x is 0.84 times 8, and then add 304. So I'm just doing simple algebra to get that. Which, toss that in my calculator, I get 310.72. So my conclusion is the ball would have to travel approximately 300 yards to be at the 80th percentile. So for the first few problems, we started with some x value. We converted that x value, we standardized it to get our z-score, and then we could get our p-value or probability value from table A. Okay, and then in the most recent example, we switched that around. We went the other direction. We started with the p-value, knowing it was 80%. We used our table A to pull off the z-score, and then we went back to the x. So you're kind of always going to be going one of these directions. But that z-score, that standardized value, is kind of the key. In our next video, we're going to learn how to use technology, and we could completely avoid table A, but understanding table A is really helpful, and you'll find probably that it's a little quicker at times, especially with multiple choice questions, just to refer to table A.